Okay, I'm going to continue to introduce some stuff of a practical nature for the group coursework, okay? But I'm hoping that the entire class is made up of grown-ups and that your aim in being in this class is not to pass the test, but to be prepared for the rest of your lives, for your employment in the future, because really there are some things that you may not use for your courseworks that we will teach you. But these things are things which I know by talking to industrialists that I work with regularly, are things they're looking for in their employees. Okay, so although there may not be marks in the exam or the coursework for some of these aspects of what we talk about in these lectures, there are people out there who will be looking for you to understand and know about this sort of thing to take you on as an employee in future. They really do. And they want you to be good technically. That's a very important part of what they'll be looking for when they're looking for an employee. Are you technically capable? But one or two of them already said to me, basically, if it says Nottingham University's computer science on the degree certificate, then we know that they're going to be technically capable. They already know that. But what they want to know is, can you work in teams? Are you capable of doing differently from the way you've seen those apprentice people do? When you're working in a real company, you need to be able to make sure the rest of your team give as much as they can and get as much out of it as they can, as well as yourself. Okay, that's an important lesson for the rest of your life. And that's one of the major things we're trying to teach you. And so when you work in your groups, yes, you're going to get marks for it, but, and Gail's going to put up she's already put up some more detailed things on how those marks will be assessed for this particular coursework. But I am more interested in companies coming to me and saying thank you, as they have done in the past for our graduates. Thank you. They know what they're doing, but they also know how to work with other people. They know how companies work. They are professional people that we're feeding into them. So today what I'm going to go through is a set of notes I've put up, and Gail had put up the previous set of notes before. I've changed them, so if you've downloaded the notes more than about 10 minutes before this lecture, then you'll find the notes I'm giving you are slightly different from those notes. If you've just accessed them just now, these are the ones that actually go with this this particular lecture. So what I've done is, do you remember what I did? I can't remember if it was a week or 2 weeks ago, where I started introducing my snakes, or rather my poles and ladders game that I was going to do. So what I've tried to do is take that as a user story and develop some use cases out of that user story, which I put onto my own Trello board, which I'll show you at some point during this lecture, and then develop tests off those, unit tests off those, then develop code based on those unit tests. Okay? I've then, before I did that, I actually did in my Git repository, I do a branch that's specifically for the piece of development I'm doing. And these are the sorts of things we will want to see in the lab when we come and look for your demo, that you've actually been doing these things, right? We will expect to see those things. And it's going to be me this Thursday who will be at your lab and expecting to see these things off you, right? When I come to your group, you will show me what you've been doing on Git, and I will be able to see on there that you've made branches for the different bits of your work, your different use cases. I will want to see on a Trello board somewhere, or some equivalent of a Trello board, unit tests that you have been trying to do. Now, the unit tests may be use tests, as I call them, rather than formal unit tests. that specify what you're testing and what your expected outcomes are. And I think the way I've done the ones for this is not perfect by any means. I wouldn't give myself 10 out of 10 for what I'm going to show you today. But basically, you should be hitting something like that if you want to see yourself getting 8 out of 10 for your work, right? So I've been showing you some use tests, the way I put it onto the Trello board of what I'm expecting. So I've got the test, and then what I'm going to test and what I'm going to expect as the outcome. And if I don't get that outcome, what have I done to repair that and make it better? And that should be evident in your work that we see online when we go to your demos. There should be evidence that you've been through this process. Hopefully you will also use pair programming. I've been working on my own, so you won't see any evidence of pair programming in my work. As I'm the only person assigned to the project, that's not possible. If you would like to take my code, some of you may find that there are things I do today that you will want to be able to do in your stuff, and there are one or two little quirky things which are difficult to do, and you might find it more difficult to find a tutorial online that my stuff will help you to do, that you might find quite useful, particularly if you're going to be initializing a lot of separate other data types, other object types, with their own classes. So there are some things I found that I can do that allow me to access these things, and I'm not sure I've found a good tutorial on them online. They may be there, a better tutorial than I've done may be there, but okay. So what I'll do, that'll come up today, and so you should know by the end the sort of thing I'll be expecting on Thursday, and Gail will be expecting in subsequent Thursdays. And so my backlog comes from the user story of the Pipes and Ladders game, which I spoke about before. You will have remembered that I have a board. I've also started. I will want to have a square, each of 80 squares that are on the board and 1 square that is off the board. So there's a total of 81 squares that are valid. You'll see in my notes I go a bit far because I want to do some unit testing demonstration as well. And so I've got, what if you try to create a square that's outside of that limit? What do you do then? So my board, my square, my counter, eventually there'll be counters, there'll be a player counter and a non-player counter, or a number of non-player counters in the game. I've basically done the board. One of the things I've done after the end of this lecture is to actually extend the board and add to it something which stores the board's characteristics, which helps me to do my unit testing for where I'm placing my squares. But I'll come to that if we get to that point at the end of the notes. So now, if you looked at my Trello board, you'd see the thing that I've checked out at the moment is the square. And I've done a number of things already, actually. One of the things is that it will have a number, and I've already implemented that. By the time you will get to the end of this lecture, you'll see how I've implemented that. I've done the use case, and I've done the unit test, and made sure that unit test passes in my time. And the reason we're going through that, some people who've never done unit testing before say, aren't I ending up doing lots of coding that is actually not going to be useful? And the point of doing unit testing and doing it through unit testing is you drive yourself at what you actually want to produce, what is actually needed to be produced, and instead of producing a lot of code that you never use at all, you produce tests which direct you towards the code you actually need to develop. And that, in the end, reduces the amount of code you end up writing, doesn't increase it. When you first start doing it, you think, this is frustrating, why am I making this test? But what you basically do is focus on what you need for your code to work, for the outcome that you're trying to achieve, rather than, oh yeah, I'm going to need this and that and the other, and build that, and you never actually end up using it. And in fact, for a lot of it, you end up having to delete it. I can think back to the first ever bit of object-oriented programming I did, which was way back before most of you were born, probably. And it was the first time I'd ever done object-oriented programming. Before I did it, I'd always been a imperative programmer only. Yeah, I used C, and I was trying to now use C++. And my entire approach to the program creation was wrong, and I produced a very poor, slow piece of code that didn't make use of the object orientation concept. By the time I had refactored that code to something that was actually of value, I'd learned the lesson about doing unit testing and writing the code that actually produces the end that you want. So the idea of doing this, the formal idea has not been around all that long, but the idea of doing it this way has been around for quite some time now. So we have a square type. Is it an empty square, a ladder start, a ladder end, a pipe start, or a pipe end? That's the type of squares I've got. We have a number of use cases. A square must come into existence. Now, this is one that the books on unit testing start you off doing. Not entirely sure that one's that necessary, but I've done it anyway, just as much as I can. But the next one, a square will have a number, and there will be a number of test cases for that square must have a number. So the square exists is if you were using a unit testing system like the one that comes with Visual Studio, you would have a simple assert test that you could do. Assert exists square. Yeah, that would be the type of test you would do, and it would fail straight away because you haven't invented the square. So you would then invent the class square, and you would say, and you would do a constructor for it, and you would say assert exists square, and square equals new square or whatever, and it would pass, right? Now, as you're not doing that, you're doing Unity, your square existing will be something that I think you could assume, because you've just done a create thing for your square. So let's say what we're more important to do is to tie that to a prototype that you can use. So if you look at my little picture here, and can I get this to be bigger? Probably not. I've got my 80 squares. I haven't got my 0th square, which is the home place before you. When you throw if you've never played this game, when you throw a dice, you move on to the board. So you can throw anything from 1 to 6. So you would move onto the board from an off the board position. So I've got square 0 is my off the board position, and square 1 will be this square here. Square 80 will be this square here. And actually 80 is the target square that you want to get to. The top left-hand corner is the target square. So once you've reached there, you've won the game, as long as you've got there before the other players. Right? So I invented a square prototype, which you probably can't see. This is a good reason why you can download the notes, and I like you to have access to the original notes, because I do a lot of overlays of things. But here you will see in the top left hand corner of my screen, once you get there, the prototype is invented. Simple prototype at the moment. I hope my microphone is going to pick this up. So it's got a transform and then I've added a script to it that will be the thing that we're actually doing the tests on. Yeah? And it's called a square script, and I did that by saying add component and then new script, and I called the script square. Right. So, oh look, I've done some blow-ups of this, that's what I'm saying. So, square prototype, can you see, read that at the back now? So that's the thing in the top left-hand corner, up here, it says this. And then over here, it's got the square position transform. So my prototype square starts off at position 0, 0, 0. If you look at my code for my script by this stage, it has got a thing declared as a number, and here is where I can adjust the number by hand, so I can do a number of tests to see if I put in an invalid number in here, what does my code say about the square that comes into existence, right? So I can do a test, and I have a basic concept for my square. It must have a number between 0 and 80. Yes, there's 80 squares, 81 squares in total. 0 is the lowest, is the off-board square where my counter will exist before it played. Square 80 is where it finished. So if I put in a -1 here, or let me say even more, a -2, that should be a fault state, and my code, my test should catch that and do something with it. Now I've decided in my lecture preparation that the fault state will be a -1. So if I know a square, if somebody tried to create a square, or somebody using my square object tried to create a square with a number greater than 80 or less than -1, it would end up with a -1. So any -1 is somebody trying to do something wrong. Okay? Now, not necessarily as easy as that all the time. Sometimes people would, in their code, would end up with something which is not a number. That would be a bad thing. How do I catch that? What do I do with it? You can look it up. Now, at first, this is a prototype, but I'm going to drag this into somewhere where I can save it as a prototype type, and then I will delete this square prototype, and then I will use it in my program. And as I said here, it has a script that will define the square. So, the program at the moment is very simple. It says class square, mono behavior, integer number, and these start and update don't have to exist at the moment. That's what you get if you create a new class. The thing that I've added is this public integer number. So I've already got the test that the square comes into existence. If I run the program, this square already exists, so it's going to have to come into existence. The square should have a number. I need a way for testing this. At the moment I have no way of testing this. So what I'm going to do is use the debug.log method. This is a method which still exists in the Unity programming system. You can use this, and you can put in anytime you want a debug.log method and actually get it to send a message to the error logging or the debug logging place, which you'll find is the bottom of the screen, and it will write to the bottom of the screen. When you've got the game screen up, it should write everything you write to the debug log should end up in the bottom of the screen. So it's a good way of faking up your own proper unit tests. You can use debug.log, and I may have used debug.log to print the number of the square when it comes into existence. And I put that in my start method, so I've added that. This is my test then, is debug.log number. It should write this number, whatever that number is. And if I just run it as is, it says debug.log object gives me 0, which it should do. That's the correct thing. If you look back, to here. That was a number 0, so that's what should come out. Yes? Diddly-dee-dee. And it comes out there. So my first test has passed because it's given me the answer I wanted it to give me. But that's no use. What should happen if I change the value in the inspector window? Then it should still give us the number that's in the inspector window. Do you know what I mean by the inspector window? This window here. This number is the number that should come out. Yeah? Okay, so I'll put it in a valid number. I put in a 1 and out comes a 1. So yes, the test is still working, right? But when it runs, the correct number appears. Yeah, great. It's gone off screen. Now, as I said, the real numbers should be between 0 and 80. So if I put in -2 or 81, the thing should currently fail. Now, if I were to run it at the moment, it wouldn't fail. It would just run and debug and log these incorrect numbers. So in this case, if I put in -2, out pops -2. Why shouldn't it? So what I have to do now is write code that will prevent the error situation from happening, right? So what do? If the number is greater than 80 or the number is less than 0, then make the number be -1. That's my default condition that I'm setting for my belief in this class. My class shouldn't be allowed to do that. So now if I put in -2 or 81, it should fail, or rather it should type -1. And if I put in, say, 50, it should come out with a 50. And here I've done it where I put in -2 and I get a -1 out. Here I've done it where I put in 85 and I get a -1 out. And here is when I put 50 in and, I put 50 in. Why did I do it back to front? I put in 50 in and out comes 50. So it's passed for those things. It's all of the things have worked as I designed them. And that's what I'm trying to get you to do. Design your code. And your tests should check that your design is working. Yeah? That's your intention. As you do it, make sure your tests test what you really want to happen and not something else. Okay? There's plenty of other stuff like code I could have written here. Because I've done this stuff before, so I could have written loads of different bits to my code. But would I ever use them necessarily? Yeah? Now, I know there are some things I'm going to need. And a terrible temptation is to go and put those in right at the beginning. But instead of developing the code and making sure the code is doing what I really need it to do at this point, I end up writing other code which maybe at the end I never use. Quite often in the end I never use. Yeah? Back to my first ever piece of code, I ended up wanting integer versions and floating point versions of the same class method. And I spent a lot of time developing ones that would do doubles and not floats. Big problem. So we should develop a lot more parts of the square, but I want to look at the idea of refactoring and the idea of regression tests. And by the way, I should have done tests of the edge values of my data as well. You know, I just gave a test of 50 there, but I should also test the edge values. So 0 and a 80 should have been put in there, and they both should work, right? You should do the edge values as well as the out of range values. The edge value should be done, and something in the middle of your test. You know, you could do everything from 0 to 80. You'll see in a minute that when I start using it, I do actually test that all of them work. But at the moment, you should definitely test the edge values. 0, 80 in my case are the edge values. Right, so I've invented the class square. Now what I need to do is populate my board with squares, right? At the moment, I've just got one square, which I'd have to physically move to where I want it. But I want to have the squares so that they all are automatically placed. They also all need to be automatically numbered. So what I did was to invent a spawner, and I call it a spawner. I don't know why. This is the name I was brought up with. I think somewhere there's a tutorial about doing Unity and about spawning objects from prototypes, and it calls it spawner, and that's the way I often refer to it, my spawner. In this particular case, it's actually going to be ultimately the game controller that I use, and I would much better call it the game controller. One day it will become the game controller, but at the moment all it's doing is spawning new squares. And it will have to have a method of its own to spawn new squares. At the moment I'm going to do it in a very blunt way. I'm going to create a number of squares, I think 5 or 6 squares, some which are valid, some which are not valid squares, and that will allow me to do the regression test on my code that I've already tested, but it will also allow me to extend to doing a loop and so on. So here I've got my thing, and I put in, oh look, I didn't call it spawner, I called it square controller. I should have called it game controller really, but anyway, I called it square controller, but I have called the code square spawner. Okay, so I added an empty game object. So this, if you see it, if you go into the controls in Unity, you say new object of type empty, and you make an empty thing here. Just because it's empty, it does have a location, and its location ends up being 0, 0, 0. But this transform is one that's totally irrelevant. I also dragged the square that I used to have off the game and put it in here, and then deleted it from the inspector. So it's gone. The hierarchy, that original square prototype no longer exists, but this real prototype, square prototype, does. And here's my script for my square spawner. So this is what I do, is it just creates a simple square called square1, and it uses an instantiate method, and the thing it instantiates is a proto square there. And now I try to run it, and I get a real error this time. And in fact, there was a good reason why it was a real error. It says, if you can't read it here, it says unassigned reference exception, and it puts a bang inside a red warning hexagon. Is it a hexagon? 1, 2, 3, 4. Yes, hexagon. Saying warning or not warning, wrong. And I should have expected it, because I hadn't put in the thing that I wanted to be spawned. Okay, so inside here, this is the thing I'm going to spawn, and outside here, I haven't told it what it is. Right? You must, can you see that? Somebody's looking like they can't see it. So here it says none game object, that bit down the bottom of the board. It says none game object, because I haven't put anything there. That's why it failed. And so it says no unassigned reference exception. You've called the variable proto in square spawner. It's not been assigned. So I dragged in the prototype, and the error went away, and instead I got a 0 out here. So our first regression test has passed. My square thing still works, right? A regression test, I've made some changes, but the test I used to use still functions. Yeah? So I need to add an array of squares. But all of my squares will come out as being square 0. So something needs to change. I've now got another error. Square 0. My test should say each square should have its own number. Okay? All squares should have a unique number. So my unit test becomes, which I've already failed by the way, each square should have a unique number. So we change the code to solve the error. So what I do is to make all my squares have a different number, and yeah, and that code, that's not come onto the screen there. I don't know if I can even move this. So this is an important bit of code that I think you would like to know. If I want to use the method that's attached to the square, in fact the start method that's attached to the square outside, and I want to get at this thing, the number here, I need to be able to get at it. And what I do is to do a get component square dot number equals, and then whatever number I want to put on it. Yeah? Got it? So if you're instantiating something else, and that thing has got a method, and you want to, has got a class, not a class, yes, a class, a piece of code that you want to run, then what you do to do it is to say get component, right arrow type bracket, and put in the method name, not the method, the class name, without the .cs after it, yeah, and no quotes around it, and then you get it, and you get access to it, and you can use it, right? So those of you who are getting into the code, that's something you might want to do fairly soon if you're doing lots. I've just randomly chosen some squares, put some numbers in, deliberately put in wrong numbers to test that my regression test works. My test that I had before should still work now. And yay, they do. The two numbers that I tried to make that are outside of bounds go to -1. The 0, the 1 and 80, they all work. Yeah? Yeah, I don't know why it says squares 50 and 51, but there you go. But that was not a very good bit of code, was it? Every line I make a new square, I write out in length. I've got to do what's called refactoring, right? What should I do to refactor this code? In a loop. Thank you. Thank you for responding. It was sometimes these obvious things people don't want to respond because, oh, isn't that obvious? Yes, it is obvious. Put that spawning into a loop. Yeah. So I put it into a loop, and I get all these square prototypes cloned up here. 74, 75, 76, 77. I did some stuff in my code to put in some errors, which all get put out. And we're still putting squares in the place. And, I clicked on the 0, 1, 2, 3, 4, 5, 6, 7. I clicked on this one, and this is what was seen in the inspector, the clone square, but its number is 7. And the answer 7 will be in here. Whoops, where have I gone? Where have I gone? I've lost it all. So way up this list, before I got to 74 here, there was number 7. And at number 7, the answer was coming out right as 7. Actually, yes. Yes, the set number 7, because number 0 has 0 in it. Okay, here's my refactored code. This is the actual loop that you need. This was done just to test the error conditions. So -2 and 85. and I have no understanding of why I reinstantiate square 50. That was a bit of an error when I was typing. My code no longer has that error line in it, but so each of the squares gets assigned the appropriate number I, and I do it for I equals 0 to 78, and then for squares 79 and 80 I deliberately made the numbers outside of the range. That's not what I would normally do. I only did that to do the test. Yes? But it worked. And there we go. And what I'll do is get rid of that. And here is my Trello board. So, what I've done now is to move on to start doing some more work. So I've invented some more tests that extend the maker square, and it defines where the square is going to go. The square's got to be somewhere. Yeah? What I want is a location on the board that the square is. Now, it's fairly obvious where those locations are to look at. The square should be where the little picture of the square is. Yes? But how do you define those in a piece of code? Right? So one of the things you could know is a square, no, that's the one I've already done. A right edge square will be half a square from the right of the board. Yeah? Pretty obvious. A left edge square will be half a square from the left of the board. And everything else will be spaced evenly in between. So I can set up unit tests based on where the square should be and discover from the code, running the code, where the square is. And if the square isn't where it should be, I've failed. Once the square is where it should be, I've passed. Right? May sound a bit dull, but to intentionally code, you need to know what you're expecting to get out of your code. Boring as anything. Okay. The other thing is I did make sure to create a branch. So this is my network graph. The GitHub is a public GitHub, the poles and ladders. So if you want to get it, it's there. No, it's not there. Top. There is the opportunity to fork it. So you coming in as not me, if you were to fork it, you could then get the code if it's of any value to you. Okay? It might be a helpful reminder of how to do that, accessing bits of classes that you need to be able to do. Like, you'll have a class, you'll have a scoreboard, and the scoreboard will have values on it, and your game controller needs to write to the scoreboard. Yeah? So it needs to get hold of the scoreboard's text value, but it also will want to keep the scoreboard's score up to date. Yeah? So you need to be able to access that score and put it down there, right? Or else, well, you need to know whether your game controller is in what jobs each of your parts are doing. That's my thing now. Can I, if I just go, and you don't want to look at this email that I've just been writing, is your desktop like this? My desktop is like this. I'm an ADHD person, and clearly, if you saw my physical desktop, it's almost as bad as that. If I bring up my Unity program, this is an old version, 5.1.4. So you'll see some progress on my other unit tests. Here I've got my square controller, and I've got a board sprite here, and I've added board locations to my as a script here, and I've got the left is at minus 6.35. So if my thing is half a square and my square is approximately 0.5 across, then my first square, the first square that appears on the board, should be at minus 6.35 plus 0.5, yeah, roughly. My square isn't exactly 1 across, so using that value doesn't completely work. But if I run the thing now, I've already done some coding, and down here come all of the various things. I can't remember which square this is where the automatic thing is bringing up the squares to be in the middle of the screen here. So it's not in the right place yet. My code needs to be changed so that each of these squares goes to where they actually should be. I can find out where those squares should be just by, this is square 0, so it's not the right one actually, it should be square 1. This square should be going down here somewhere and across here a little bit. There we are. So that's where I would expect square 0 to be down, square 1 to be down here. Square 0 will be invisible. If you don't think games should have invisible pieces of stuff, just talk to Gail, whose PhD involved making all sorts of things not visible to people who were using the system she developed for her PhD. So we do that sort of thing. There we go. I could show you a bit more of the code, but I've been working through the unit test, and it takes relatively little time, much less time, for me to code intentionally than it does to think about, oh, what do I want to code? Oh, I'll code this, write lots of code, and then eventually come to the point where actually I never used that, and that happens all the time if you go that way. If you intentionally code, you get so much less time spent creating things you never use. Any questions? Any questions you don't want to be recorded? Because I will stop recording now if you